Hello and welcome back to another episode of Math with Sohn. Today we are going to be going over Unit 1 and Unit 2 to figure out what do we need to know for the test. So I'd like everybody to write this down and get this right so we can do well on this test. So one of the things that you are going to absolutely need to know how to do is when given an absolute value or a parabola, like y equals 3x minus 7 plus 1, you need to be able to look at that and just absolutely know what is happening. So for starters, this went to a change the sign, keep the sign. So this is 7, 1, which would imply it went to the right by 7 and up by 1. Okay, so it went to the right by 7, it went up by 1, and this 3 indicates that this is a vertical something. It is vertical. As far as stretching or compressing, that is based off of the fact that it is vertical or horizontal. And if you think about it, if you had your arms here, and the reason they're squiggly is because somebody is pulling them either out or in or up. If somebody was pulling on your arms vertically and therefore making you skinnier, because this would get skinnier if it is a whole number, it is skinny. If it gets skinnier, it would be considered stretching you out vertically, and that would be this scenario. And you would be in pain. All right? So, change the sign, keep the sign, and vertical stretch. You need to be able to identify all of those things, but you would also need to be able to identify it from a graph. And if we were to graph this, an absolute value graph is right by 7, up by 1, and a slope of 3, so it would look like this, but an absolute value graph is a V. If it was curvy, that would be a parabola, but absolute value graph is a V. And not only that, but this is like a 3-question piece of notes. You have to answer one question where it's like, hey, how did it move? Right, up, left, whatever, and vertical or horizontal. You have another one where it's like, given the graph, write the equation. But more importantly, and lastly, not necessarily more importantly, is that the minimum is just equal to that last number, or it could be the maximum is just equal to that last number. Both of them are just the last number. It is the y value of the vertex. All right? So I'm looking for all of that on your paper. Moving on. Another thing that you need to know how to do is if you are given an absolute value equation, what would be the 2 scenarios or equations that you would end up having to solve? So given this, the first thing you would have to do would be add 4 to both sides. 2x plus 3 equals 5x plus 10. And then divide by 2 individually, leaving us with x plus 3 in absolute value bars is equal to 5 over 2x, and 10 divided by 2 is 5. From here, you do not change what is inside the absolute value bar. You change what it equals, because we're not actually plugging in something into the absolute value bar. We're setting up the equation. We're solving it, which is a different process. So you solve it by changing not what's on the inside, that remains in x plus 3, but you have one version where it is positive everything, whatever it was, you keep it the same, and another version where the x plus 3 remain the same, but you distribute or change the sign of everything that was over here. So these were both positive, now they're both negative. If either one of these were negative, they would flip, become positive. Whatever they are, they change the sign. This would be the 2 scenarios that you would end up with, that you would have to solve. All right? Moving right along, that's like 4 questions on our test right there. So moving right along, let's continue this path of success. Let's see, what else do we got? Oh, we got even versus odd. Even versus odd. So you need to be able to look at a graph and just automatically know if it's even, and it's even if it is looking like this, if it's symmetrical and it folds over butterfly style. So this would be considered even. However, something like this would be not even. Not even, it's not odd either. And the question that you will have is just, is it even? And not even. But you also have to be able to pick it out if it is something like y equals 10. That is a horizontal line way up here at 10, and that is even. But if it said something like x is equal to 4, even though 4 is an even number, x is equal to 4 is a vertical line, and that is not even. It is only even if it's y is equal to, but you could also say like h of x is equal to, because that's the same thing as y. It has to be a y equals line, not an x equals line. And then you get into the scenarios where it's not graphed, and it's not an easy equation, but it's something like this. Y equals x squared plus 3x plus 7, and y equals x to the fourth minus 5x squared minus 3. One of these is even and one of these is not. If, here's something I've learned last week, believe it or not, if all of the exponents are even, see how here we have a 4 and here we have a 2, and here technically you don't have an exponent, it's like just 3. It's the exponents on the x's. If all of those exponents are even, your function will be even. Now that's not the only way to do it by far, but if all of the exponents are even, if the exponents are even, I'm going to write it because I want you to write it. It equals even. Here on this one, we got a 2 and we have a 1 because that's x to the first. Not all the exponents are even. We have an odd exponent. If we have a singular odd exponent, it is not guaranteed to be even. And normally, if it's not guaranteed, it's not even. Okay? So all the exponents are even, it's even. If one singular exponent is odd, that 3 to the first power is an odd exponent, even though that x squared was even, it's not even. Moving right along to end behavior. As x approaches, let's go with infinity, f of x is approaching negative infinity. That means that we are on the right side and we are going down. So out of the few graphs that I graph, we need to find the one that goes on the right side down. This first one on the right side goes not down but up, so this one would have been x approaches infinity, f of x, or y, is approaching positive infinity, not the right answer. This one is just a line, so this would also not be it. Nope. And this one is going to be our winner. And I'm even going to curve it up because why not? On the right side of the graph I am going down, this would be our correct winner for end behavior. Continuing and continuing. Let's see, what is the other? Yeah, here's the last thing that we really have to go over, and that is graphing something like this. X plus 3y less than or equal to 5, and x is greater than or equal to negative 4. The first graph that I would like to do would be the easier one, the greater than or equal to negative 4. And it is a solid line at negative 4. And it would be shading to the right because greater things are to the right, but every other graph other than vertical graphs are just, up or down. If it presents you with any equation like this, you need to first subtract the x over. So if we subtract the x to both sides, you would end up with 3y is less than or equal to negative x plus 5 because they do not combine. It's not 4x. and then divide by 3, divide by 3, divide by 3. And I know for a fact that one of your equations will most likely divide by a negative. If we had divided by a negative, we would have had to flip the inequality sign. We did not divide by a negative, we divided by positive 3. Therefore, my less than or equal to stayed less than or equal to. I also think that you're going to have a decimal on your test. I'm not sure, but I think that you're going to have something with a decimal, and that's okay because you're just picking out of a lineup. 5 over 3, if you divide it, is about 1.6. Repeat, it's not even about, that's exactly what it is. So if we went up by about 1 and 0.6, and then we have a negative 1 over 3, I forgot my x for my slope, we would have to go down 1, right by 3, something that looks kind of like this. But more importantly, which way would we have to shade? If it's less than pointing to the left, less than pointing to the left, we shade down, and the overlapping area would be this area right there. And we'd have to find that on our test. I got one more problem for you, and we are gonna be done for the day. Thank you so much for following along. Last one. X plus y less than or equal to 2. X plus y greater than or equal to negative 2 versus x plus y less than or equal to 2, x plus y less than or equal to negative 2. If you had to know what the graphs look like, first off, pay attention because you're not going to want to solve for y on 1, 2, 3, 4 equations. That's a lot of work. As long as the y is positive, then the shading will mimic to down and up. So all of these, the y's are positive, and all of these are going to be shading according to the less than or greater than or equal to the way that they look right now. We don't have to solve for y because y is positive if we can identify which line is which from the answer choice. And the answer choices are going to be pretty obvious. They're going to look something like this, and you're going to recognize right away, which one's which, because negative 2, that's the one that goes through negative 2, and positive 2 is the one that goes through positive 2. If I want to be less than positive 2, I would need to shade below the positive 2. But if I want to be greater than negative 2, I would have to shade above that part. And where do they overlap? Well, that would be in the middle. Versus over here, where it's the same exact equation, but now they're both less than. So when I graph both of these, if I'm going down and I'm going down, well, yeah, if I went down below this line and then I went down below that line, the only area that should be shaded would be the part that is below both of them, which would really start below the lower line. Okay? So that was going to be it for today. Hope it wasn't too painful for you, but stay positive, and I will see everybody later. Bye.